Huh.
Hello.
Hello.
Yeah, ready.
It's only me.
Yeah, it's only you, extremious.
You forgot the ace.
Yeah, ace. I don't have a kit right now.
Okay.
Are we waiting for more guys to join?
Yeah, we can wait for 5 minutes.
5 minutes. Okay, I don't see anybody. Anyways. Okay.
So what's the topic about?
You've all got your Miam,
Yeah.
and now that the Miam is ready,
No,
the
it's not. You
why
can
isn't
make it.
it ready? What's the problem?
It's too tight. The
Oh, let
the
me get
parts
my
are too
Miam.
tight.
Yeah, this is the Miam that I've got. So this is how it should be once it's connected. I mean, built.
My one's too tight. Like the screws aren't fitting.
These screws.
Yeah. Like some are too tight and some are too loose.
Okay, so if it's too loose, then you'll have to tighten it. If it's too tight, if you're loosening it. I mean, I know that's easier said than done. Uh, okay, one way in which you have to. Okay, the one thing that you have to always remember when you're connecting the Miam is there are no nuts in this. There are no nuts that are used to tighten or hold on to the screw. So if that is the case, what they've done is they've reduced the diameter of these holes here. They reduce the diameter. Say if you're using a 3 mm bolt, the diameter of this is about 2.8. So a 3 mm bolt will get through, and when you start screwing, it will automatically create a thread and it will get tightly fixed to the board here. Now that shouldn't stop you from rotating this. Okay,
No,
so
like
if you tighten this too much, then it'll cause a problem.
the claw is too tight.
Yeah, claws are too tight even in my case. So if you look at this, it's too tight.
No, like I can't even get the screws over there.
Yeah, so what is the problem here is this. First thing is you have to loosen this part.
Okay.
This part. Okay, so how you check it is if you find this part to be tight, so you see which part is connected to this directly. It's actually sandwiched in between these two plates.
Uh,
Because it is sandwiched in between these two plates, you loosen this a bit. Okay, don't loosen this too much so that you get this ply here. Okay, you loosen it a little and then try.
I'll try.
Yeah, that's one thing. The
Maybe
next thing,
the
yeah, the next thing is just start connecting to the next interlink. Now this is the first interlink, and from there it gets connected to this here. and this one is also another one. Loosen this a bit. Loosen, when I say loosen, it should be like about half a rotation. That's about 180 degrees when you turn. It loosens a bit.
Hmm.
Okay. Whatever is in the center should actually go free in between the both the bolt and the thread. So this is actually a little free here. If you see, I can see this moving a little.
I
Even
think
this.
the mistake I made is that I put 12 mm's bolts instead of 8 mm's.
If you use 12 bolts and stuff, okay, the easiest way to understand, I mean, how much, what's a bolt that you have to use is when there are only two plates, you have to use 6 mm.
Okay.
When there are three plates, 8 mm. When there are four plates, 10 mm. That's
I
how.
went the I went the lazy way and put all 12 mm's, and
No,
then I'm
because you don't
I'm
have
stuck
so
with
many
6
12
mm.
mm. You will run short of 12 bolts very soon.
Yeah, that's what happened.
Ah.
And then I tried to get them out, and yeah.
Yeah, okay. By then you would have actually increased the whole diameter. They may not fit back again. All that is a problem. So you have to pay attention to how the design is done. Like there are steps and follow those steps precisely. And they would have given you the top view, side view, and front view. We of course have a video of this ready. It's in the editing process. The assembly video of this thing. We will have it published very soon, probably a week's time. We will have that published. But I see that you don't have a problem. So what we can do is, if you have a problem, we'll, like when we meet on this Friday for the class, let's look at it individually, and I'll tell you which are the points where it's tightened too much. Then you have to loosen it, and you should be done. You will be done with it. So basically, the robotic arm here should give you an extension like this, and when you rotate, you will see this servo motor here also rotates along with it.
Okay.
And you also get that sound of the servo gears inside. Now that's one. There's one, the claw, and then you have the one which actually makes it go forward, up and down. So this also is connected at 2 points. One is here, here,
I
three
just
points. This
I just
one,
can't finish the claw.
2, and 3. These are 3 points at which it's connected. So you have to loosen here, loosen this bit, and loosen this bit as well. The first thing you would have to loosen here, because there are, yeah, the moment you loosen that, you will see that this will be able to go easily. Okay, and then you go for this, you will see that it will work well, and then you will go for this one. So this should be very loose, not so much that you have shaking out, I mean shaking up here. There should be no gap here. When you look at it, there should be absolutely zero gap here in between this. The gap should be so much that a paper can slide through in. So if I take a sheet of paper and try to slide, put it in, a paper should go in easily. That's all. One sheet of paper should go in easily from all directions. That is how it loose it should be.
How can
And
you show it again? Like I have the thing in my hand. I'll see. No, the back view. The back from
this
the back.
gap, yeah, I'll show you. This gap, you should be able to just slide a paper in through it like this,
Okay.
through that
Yeah,
gap.
I'm done with that.
Yeah, so that's how it should be with all these pins. I mean, all the screws here and here and here. With this, the next side, they're like now more than one. The first part is this. So see to it that this one is loosened. And then comes is this,
Then
and
it's joined.
yeah, cool. So you should be able to easily move around. Though I am affecting the servo will eventually wear out by doing this. It's not advisable to do this, but at least when you're testing your board, this is something that you have to do. Another way of doing it is, now that you've written a servo program, if you watch the previous videos that you've done, we did the servo program. Connect individually each of these servos to your Arduino board and check for the working of this servo. Now here you should never keep the sweep to be 0 to 180 degree. Just ensure that the sweep is anywhere between. For this it should be somewhere close to about 60 degrees to 120 degrees. That's what it is. And the instruction document tells you what angle this motor should be at, what angle this motor should be at. And for each of these motors, the sweep is different. For each of these motors, the sweep is different. And because the sweep is different, you will have to set the sweep in the servo program. So I'll just show you.
What's a sweep exactly?
One second. Screen sharing. Why isn't? Okay. Can you see my present? Okay. Can you see the Arduino file? I mean the ID?
Yeah.
Yeah. So when you look at examples, servo sweep, the sweep program.
Yeah.
Yeah. So when we connect to connect individual servos to the Arduino board and check, you will connect it to pin number 9. Now the sweep is what I'm telling is 0 to 180. When I say 0 to 180, the Arduino will, the servo motor will start rotating from 0 degrees all the way to 180 degrees, and then it starts rotating from 180 degrees to 0 degree. So here I am setting the limits as 0 and 180. So the servo motor will rotate between 0 degrees to 180 degree with a delay of 15 milliseconds in steps of 1 degree. So what I will have to do is here I will have to set this to be somewhere around 60 and then set this to be 120, and here I have to make it 120 and then I have to make this 60. So that time what happens, my servo motor will now rotate between 60 to 120 degree. So it will go 60, 61, 62, 63, 64, 65, goes all the way up to 120 and then starts decrementing from 120 to 60. So that's the sweep that I have to set. So for each of these motors, it's different. Say for the claw motor, the value is anywhere between 0 to 90 degree. If that's what you have set. So you have to calibrate this, the initial calibration in your document, which says how to assemble your robotic arm, tells you what should be the sweep angle for your servo motors. Each of the servo motors, the claw motor, the base motor. So it's example for the base motor, it is 0 to 180 degree full. It can go full swing because there are no obstacles. But for your claw motor, you can't do 0 to 180 degree. If you do 0 to 180 degree, the motor might get jammed. So you have to see what is the maximum angle that the motor will go and what is the minimum angle that the motor will go. That is something that you have to do. So another way of doing it is to check individually what is the maximum angle or minimum angle is just put here something like 90 and this to be about 91 and then say 91 and 90. So what happens here when you do this is it will stay, the motor will now go to 190 degree, or you could also do one thing which is not what I've done now is not right. So you can just say this. So you would just write my servo right position as 90. So when you do this and upload the code, the motor will rotate to 90 degrees, or the servo motor will rotate to 90 degrees. So you know which position your servo motor will come to, and eventually which position your robotic arm will come to when you go to 90 degrees. So that is something that you have to calibrate. When you know 90 degrees, then you know, okay, fine, let me do it 80, let me put 85 and see what angle will my servo motor go to. Okay, then I'll start reducing this. The moment I see, okay, it has reached the limit, physical limit, the physical limit on the motor, which is to say, the physical limit on the motor. Say if for 90 degree it comes so much and I can't do anything beyond this, right? It's difficult for me to do this motor here, this motor, anything beyond this. I can't do it any beyond this. So this is 90 degrees. So I should ensure that the motor doesn't the command that I give to the motor should never cross 90 degree. And then this side it would be about 135 degrees or 145 degrees here. So then my sweep angle will be anywhere between 90 to 135, 90, 135, 90 and 135. Are you getting it? So individually for each of these motors, you will have to calculate. What is it for this motor? What is it this for this motor? What is for this motor? Now, sometimes for some of you, your motor may not go beyond this. It might just get stuck here, which means you've already reached either 0 degrees or 180 degrees on your motor. Which means you have to remove this and remove the servo horn, recalibrate your motor, bring the motor to 90 degree and then connect it again.
Again.
Yes. So this calibration has to be done initially. So for the claw, I think it's about you have to keep it at 90 degree. For the for the claw, I think it's about 0 degrees or something. For the rest of the motors, it is 90 degree and 90 degree here. This should be 90 degree. This should be 90 degree before you assemble the component. I can actually show you one of them. Just hold on. I might have me assembling document. I'm searching.
I think I have the document. Is it
Okay.
taking too much time?
No, I've got it. Yeah, let me just screen share. Okay, this is the document. Present to everyone. Yeah, so this is a document. Now this is the step 7, which shows you which direction your motor, servo horn should be when you start assembling. Attach the servo arms as shown below using the small machine screw from the servo fixing pad. Leave these attached until you are required to use them. Be careful. And now look at the angle at which it is supposed to be done. Where is it?
So you're giving us that thing.
Sorry?
So you're giving us the brains board.
Which board?
That thing.
Yeah, this one.
Yeah. You're giving us that.
Oh yeah, that board is coming up. We have got a board done for this. The controller board for the servos, which will be plugged on top of your Arduino, which you will get it, and then you will have to assemble your robot on that. That will be given, yes.
Okay.
Yeah. So this is how you're. Yeah. So this is for the claw. I think this is not giving you the angle. Just let me just check. Actually, the angle was supposed to be given somewhere.
Sir,
Okay.
it's 90, 90, 90, 25.
Where is it given, Shreyas?
Sir, I'm done. It was
No, yeah.
there in the size. There in the site.
Is that
I
on
went to
the
the site. Yeah.
Okay, okay.
I sent you the link.
The site for that?
Yeah, this is from MIME. This project is from MIME.
Okay, I'm on that site now.
Okay, send you the link.
No, I got the link.
Sharing.
So you copied them and like made the robot.
I did not copy anything. I've just manufactured it for you and they've given it. It is the same design. That's the reason why we have retained the Neom logo on the robotic arm as well. So this is the Neom logo, and we've just retained it because the whole copyright belongs to Neom, and because this is an open source file that's available for everybody, like how you have Arduino, we have gone ahead and used this for building the robotic arm. It's completely open source. Okay, so we'll be building our own brains board. This brains board will be, you'll get the brains board. So this is the board that
We're gonna
the
make
board.
that. You're
Sorry,
gonna you're gonna give us that, or you're gonna make. We are gonna make that.
I'm sorry.
Okay, you're giving us the brains board, or
No, we are
we're
building our
gonna
own
make
brains
that.
board. We're not using that brains board. We are building our own brains board, and that board will be able, you'll be able to use it for a lot of other applications as well, not just this robotic arm.
Huh.
So it will be a general purpose board which will have perforations. You can add any other component that you would want, and it will be an add-on board that will add directly on top of the Arduino. Okay.
Okay.
Yeah. All right. So that is with respect to this. So for first thing that next thing that you have to do once you're done with this is to run the sweep program, Arduino sweep program, and calibrate all of your motors. So effectively, your motor should be rotating. Now, individually, you can control one of these servos with your Arduino board because Arduino is capable of giving up to about 500 milliamps of current for this motor through the 5 volts and ground pin. But then each of these motors would require anywhere between 200 to 300 milliamps of current. So which may not be sufficient just by giving it through the Arduino board. So we'll need an external power supply to be given to this, external 5 volts to be given to this, which is not there currently. That's the reason why we need that add-on board to which an external power supply will be connected. And then the 5 volts and ground required for this, the power required to run these motors will be given from the other board. Now, individually, you can connect one of these motors and check for each of the motors once it's done. So you basically have to write a C program anywhere between, so that this is 180, so this is 90, yeah, 90 to 180. So anywhere between 90 to 180, this is what happens. So if you give a delay of 15 milliseconds, this is how it will be. If you give a delay of about 25 milliseconds, it will be like this, very slowly. So that's a delay that you have to give. The program that we are doing, showing, we'll have to use is this. Once you're done with this, where you enter the angles in 90 or 180. So once you're done with this, use the sweep program. Arduino file examples, Servo, sweep. Where did it go? Oh, I think this is a sweep program. Let me just. Yeah. So with the sweep program, you could change the upper limit and the lower limit, as the lower limit and the upper limit, and start controlling your robot. Okay, this is for individual motor. Now, when you have to control all the 4 motors at once, then you'll need an external power supply that can give you additional current required for all the 4 motors to be run at once, which will happen through the add-on board that we will give you. Is that clear?
Yeah.
Okay. Yeah. Right. Any questions?
Let's think.
Yeah. So this is the first part. So you will program your robot to say you would want something to say you have some say battery that is kept on the board, and then you will want to pick it up. So you will say, okay, if it goes about 30 degrees down and then goes a little forward, picks it up, open the claw and then pick it up and then pick it up here, then turn to the right and then place it down and release it. If this has to happen, then you have a set of instructions that you will write in the Arduino board. That command is happening. So which means you pre-program the controls that should happen for this particular Robotica and write in the code in the Arduino board and then upload it. Another way of controlling it is through a potentiometer. You can connect potentiometer to your control board, read the signal to the Arduino, and depending on which position you turn the potentiometer to, the Arduino will then control the servo motor position eventually. So this is the knob program that we've seen on the Arduino board.
Okay,
in
what's
the
the
example.
best way? What's the
What
best
is the?
way? Best way.
It depends on how do you want it to be, want to control it. Like if you wanted to control using a potentiometer where you decide and at random where you want to control, where you want the robotic arm to turn, then you use a knob. If you have a prefixed position and you want it to work autonomously all by itself on a pre-programmed kind of an instruction, then you will use the code. Say you say go down, pick it up, then turn right, pick it up, leave this, then again come back, pick it up, do this. So you run this in loop. So for this, you don't have to use a knob control to determine the position. If you want a knob control, then you turn the knob to the right, another knob to the right, this will come up, and then turn to the left, this will go down. So for each individual motor, you have 4 different knobs that can control the position. So there are 2 ways in controlling the robotic arm. One is in autonomous mode, like how we used to control our robots, say go straight for 10 seconds, then take a right, then take a left, and then go straight for 20 seconds. That used to be in the auto mode where you program it and leave it and it does that function. Now you want you to control every single moment, you want to control what instruction goes to your robot. Then you will do a interface mode where you will have a remote, you will write a program to receive controls via remote, either through keyboard or through a joystick. And then the robot functions according to your commands. So these are 2 methods, 2 ways in which I could program this robotic arm. Arduino to run this robotic arm.
Can we use joysticks?
Yeah, you could use joystick. So you have programs in, there are sample programs available for Arduino where you could interface a joystick to the Arduino through the USB interface. And then the Arduino could receive that command, and then eventually it will translate the command to the servo motors to rotate left, right, and right. A joystick, if you're using joystick through a protocol, which is like if you're using a PS2 joystick or
No, not that. Not that. Like
joystick knob.
No, like I'll show you a picture of the 1 minute. Save image. Okay. One minute.
Yep.
Okay. Like I'll give you a link of that.
Okay. Is this what you are trying to say? Let me just share.
I got the link.
Is this the one?
Yeah. That kind of thing. Yeah.
Yeah. So this is again a potentiometer. You see, if you see the forward and backward motion for this knob is actually a potentiometer that is connected here. So 0 to 180 degree. When you send it forward and backwards, it will go 0 to 180 degree. And the same thing happens. There's another potentiometer on the other side. So look at this. There's another potentiometer that will turn left to right when you rotate it left to right. So it's again two potentiometer which will control this. I mean, which is actually the function of this knob is translated through two potentiometers, one on this side, one on the other side here.
So we can use that.
Yeah, you could use this joystick as well. I mean, this is again a potentiometer. We could use
Okay.
this as well. Again, see, you give 5 volts and ground, and then VRX and VRY, which is nothing but voltage output of one of the potentiometers. This VRY is the voltage output of another potentiometer. The 5 volts and ground remains common to all the 4 potentiometers that you're using. So you could use one on one, say this one to control 2 servo motors, and another one to control the other 2 servo motors. Now, once this is done, there's also another way of controlling your robotic arm. This is called coordinated motion, where if you look at the servo motor, let me show you the servo motor. Stop screen sharing and then show me. Okay, if you look at this servo motor with the coordinated motion.
Which one?
Yeah, I'm showing the robotic arm.
Okay, which one? Which servo?
This servo here.
Yeah.
So if I want the robotic arm to come somewhere here, it's not just sufficient for me to do this, but along with that, I also will have to do this. So there are 2 servo motors running at the same time. Okay, this is called coordinated motion. So there is a shortest path between this point to this point. So that can be achieved by rotating this servo motor and then this servo motor as well. One second. So this and then this. So this can happen when you run these 2 servo motors together, which of course this happens sequentially. This goes 90 degree, then this goes 91, this goes 91, this goes 92, 93, 94. So you eventually start moving at the same time. So it doesn't take, say, a path like this. If it has to go forward, it doesn't take a path like this where it goes here and then again it goes up. What it does is it takes the shortest path required to achieve this point. So you'll see that 2 servo motors are rotating at the same time. So this is called coordinated motion. For this, again, you'll have to apply advanced algorithms. You have to write an algorithm where if you say you have to move from position A to position B, then you're controlling this servo motor and this servo motor parallelly to move from 0, 0 to 5, 5.
You can do that, no?
Yeah, we can do that. So that's the next stage. So with just one simple robotic arm, you would be able to do a lot of these algorithms to determine where it has to go. And the next stage would be to have a camera mounted on your robotic arm. Say it detects an object here and then you want to pick that up. So your robot knows how far to move from here. So now this is, say, 5 centimeters. Now your robot doesn't know if that is 5 centimeters. How does it decide the 5 centimeters? Maybe there's a sensor on top of this, it decides. But the 5 centimeters have to be translated into angle for these motors. So 5 centimeters on the x-axis is about 20 degrees on this motor and then 30 degrees on this motor. So that is something that you have to translate a xy coordinate into an angular coordinate or angular command. So this is the next stage. So these are how advanced robotic algorithms are written for robotic arms or control systems. And this is what happened. This is the first stage to get the robot running, and then the next stage would be to improvise on it. The next
What's
stage,
after that?
there are a lot of things. I mean, a lot of things. I mean, then you will find that this platform is not sufficient to run your advanced algorithms because the response rate of these servo motors are very low. You want to get this here. It might just struggle doing this, right? Because the servo motors are not that very efficient, and these are not designed to do a very quick response system. So you might go with something like a motor or something like a servo motor that's say brushless. There are different things that you could do, but the first step to start with to understand coordinated motion. We used to get multiple motors running at the same time. Cool.
Okay, and what's after that?
Okay, what's after that? Let's
What's
see where
level 5?
there's no level 5. Level 4 robotics is what we do till the end is, I mean, we just do till level 4 robotics. We're introduced to coordinated motion. And by then we finish 1 year to do so much of robotics. Next thing, let's see how it goes. And then we will be able to bring in new learning.
Like?
Like, you tell me.
Hmm.
Hmm.
Uh, I don't know.
I don't know. Yeah. Neither do I know, but then there are a lot of things that you could do.
Make a mini computer.
Make a mini computer. You already have a computer.
Teach
Another
Raspberry
one.
Pi.
Sorry?
Teach
Danu?
Raspberry. Teach
That's very
Raspberry.
fine. Okay, let's finish this. We have a few other things that we could also do with respect to controlling these motors with LabVIEW. That's the next stage. But then we'll have to finish this by it's October, November. Yeah, by the end of November, by the beginning of November, we'll have to finish this entire robotica, and then we'll start with LabVIEW, where we'll have advanced programming tools to control this robotica. Then you'll
Okay.
also have, you could bring in
How
a lot.
much will LabVIEW cost?
How much will
LabVIEW cost?
you want to buy LabVIEW?
Yeah, like
Yeah, I'm not authorized to sell LabVIEW to you, or I do not know the price. What it is. You could visit ni.com and then raise a query. They would get back to you telling what price is each license. You
huh.
do get student licenses for LabVIEW.
Okay, let's see.
Let's see. All right. Okay. Cool. So this by this we will end the session for now, and we'll see you on Friday for the class. By then, please have all your robotic arms calibrated. If you, in case you have any problem, leave me a message with a short video of what's happening, either WhatsApp or link on Hangout. I will look into it and then suggest you what could be done. If we are not able to fix it virtually, and then we'll meet in person and then fix it. Cool.
Okay.
All right. Thank you so much. Have a great week.
Same to you.
Yeah.
Bye.
Bye bye.